Hello everyone, I am Naresh Kumar, science teacher at Government Senior Secondary Smart School, Badshapur Kaliki, District Patiala. Students, today we are going to learn about series and parallel circuits and their very important application in our everyday life with the help of a working model. Series connection means the individual appliances they are connected end to end. Now, what happens to the resistance in series? In series, the equivalent resistance is given by the sum of the individual resistances, and hence in series, the equivalent resistance always increases. Whereas in parallel circuit, as you are looking at, the equivalent resistance always decreases because the reciprocal of the equivalent resistance is given by the sum of the reciprocals of the individual resistances. Now let us understand a very important question which is asked, that why domestic circuits are in parallel. They are preferred in parallel but not in series. So let us begin with the activity. So look here, I have connected here three bulbs in series. How it is so? The wire coming, these are two wires, red and white. The white is coming from first bulb which is connected to second, and coming from second is connected to third. And these two extreme terminals, red from one extreme and white from another extreme, it is given the 220-volt main supply. So this is called series circuit. Now, what are the drawbacks of series circuit? Why domestic circuits are preferred in parallel and not in series? The very common drawback is a single switch operation. When I make the switch on, all the appliances start working at once, whether they are required or not. And if I switch off, all will stop working. This is a very common drawback. And the second one you see here, that if one of the device gets faulty, because this is a common current path, there is no other alternative path for the current to flow at. So if one of the device, any of the device gets faulty, let us say this one gets faulty, the circuit will break and the current stops flowing. If this one gets faulty, the current will stop and each and every device will stop working. So if I call upon the electrician, he will come and he will check each and every appliance independently and to find out the fault, wasting a lot of money, lost a lot of time. So this is undesirable. And the third one is that since each device in series, it is not getting the 220-volt supply independently. Rather, the potential drop will be proportional to the resistance, as I is constant here. So higher the resistance, higher is the potential drop. Since each device is not getting the 220-volt independently, so it each will not work to the fullest. So as you are looking here, I have connected 100 watt, 40 watt and 60 watt bulb. 100, 40 and 60. Now out of these, you will be surprised to know that 40 watt is glowing to the brightest, but 60 watt is glowing little bit and 100 watt is almost nil. Why this is so? Because as I told you, V proportional to R in series and I is constant. So resistance across 40 watt bulb is highest. So potential drop across this one is highest. That is V3 is greater than V2 greater than V1. If I multiply by I, the power output P3 is more. So 40 watt bulb will glow the brightest. Let's check the parallel. So these are now three bulbs in parallel. The three white wires coming from each bulb, they are connected jointly, and similarly the three red wires, they are connected jointly, and these two terminals are given the 220-volt supply, main supply. Now this is an individual switch operation, students. Let us check. Each device is getting 220-volt independently. So each is giving its full power output. Now if I don't need this, I may switch it off and I may switch it this one as on. So this will work, but this is not working. So whichever is desired, that can be operated and it will give its full performance because each one is getting the individual 220 volt supply. And it is very easy to check the fault also because only the faulty device will stop working. So I hope you understand. Thank you.